Hi everybody, this is Mr. Bowman, and in this review video we are going to talk about the fundamental theorem of calculus as our focus. FTC1, or the antiderivative part as our book calls it, basically says the following. It says that big F of x is equal to the integral from a to x of little f of t dt, and essentially what we're saying is if we take the derivative of big F of x with respect to x, we are taking the derivative of that integral from a to x of f of t dt, which is basically saying, well, df dx is equal to the derivative. Here's where we're going to invoke the second part, the evaluation part, of big F at x minus big F at a. And the derivative, F of a is just a value, so its derivative is going to be 0, and df of dx, d of capital F of x, is dx of capital F of x, which is equal to lowercase f of x. So it relates the integral and its antiderivative. The second part, which we kind of basically looked at right there, is the evaluation part. And the evaluation part simply says that if we have an integral from a to b of f of t dt, it's equal to the antiderivative of f evaluated at b minus the antiderivative of f evaluated at a. So let's take a look at how the College Board asks questions related to that. So here's the first question. We have a graph of f prime, and it says f is differentiable on the closed interval from -6 to 5. F of -2 is 7. The graph of f prime, the derivative of f, consists of a semicircle, which is important, and line segments as shown above. Find the values of f of -6 and f of 5. So in this first part, we can use the fundamental theorem, and we can say, oh, the integral from -2 to -6 of f of t dt is going to be the antiderivative, of f prime of t dt is going to be the antiderivative of f prime, which is just f evaluated at -6 minus f evaluated at -2. Now you might ask why I picked -2 and -6. I picked -6 because I want to evaluate f there, and I picked -2 because I already know the value of f there. So if we solve this for f of -6, f of -6 is equal to the integral from -2 to -6 of f prime of t dt plus f of -2. We know f of -2 is 7, so we'll substitute that in there. And I think it's easier to integrate from left to right, so I am going to use this property of integrals that says if you switch the limits of integration, so we're going to integrate from -6 to -2, f prime of t dt, and then we'll add 7 to that. We just have to put a negative sign in front of it. So we're going to go up and figure out what the integral of f prime of t from -6 to -2 is. Well, from -6 to -2, right here, we basically have a triangle that's above the x-axis, so that integral is going to be positive, and we're just going to use 1/2 base times height and throw a negative in front of that. So -1/2 times the base is 4 times the height is 2, add the 7 to that, and if we simplify that, we get 3. For the second part of that question, we're going to do the same thing, save ourselves a little bit of writing. F of 5 is equal to the integral from -2 to +5 of f prime of t dt plus f of -2. We already know that that's 7, and you can verify that the integral from -2 to 5 consists of, and since we're already going in a positive direction, left to right, I'm going to leave that integral alone, not switch the limits of integration. Consists of a semicircle below the x-axis, hence the negative. So -1/2 pi times the radius squared plus another triangle above the x-axis. And you can verify that it is a base of 3 and a height of 2 plus 7. And if you simplify that, you get -2 pi plus 10. Let's take a moment and look at the scoring rubric. Uses the initial condition, finds f of -6, finds f of 5. That's 3 points out of the 9 possible points on this problem. So in part A, we use the evaluation part of the fundamental theorem. In part B, it says on what interval is f increasing, justify your answer. Well, f is increasing wherever f prime is positive. So we're going to use the first part of the fundamental theorem, which says the relationship between the derivative and the integral. So in part B, f is increasing where f prime is greater than 0. And you can verify that that is true on the interval from -6. Remember, we're including the endpoints here. So from -6 to -2, not including -2, and from 2 to 1 to +3, not including 3. So our answer to that question is going to be from -6 to +2, or from, I think I said 3, I meant to say 2 to +5. And again, we're including this endpoint at -6 because f prime is positive there. We are not including 2. It should be a -2. We're not including -2, 2, or 5 because f prime is 0 there. So let's take a look at the scoring. Answer with justification, 2 points. So typically, if there's no justification, you get 0 credit for those. All right, find the absolute minimum value of f on the closed interval from -6 to 5. Okay, so minimums, relative minimums, can occur at endpoints, and it can occur at critical points where the derivative changes sign. So we're going to have to make a candidates table for this and make sure that we include the endpoints. So we're going to include the endpoints. We're also going to include x equal -2 and x equal +2. So our candidates table is going to look like this: x, f of x, -6, -2, +2, and 5. Now, before we get started, we have to justify how we know to use those points. So, absolute minimums, which will occur at endpoints or critical values. And then we have to evaluate f of x at these various values. So from part A, we already know f of -6 is 3. If you made a mistake on part A, they're not going to ding you twice on this. They'll just carry that through. We also know that f of 5 is 10 minus 2 pi, or -2 pi plus 10. And they told us that f of -2 is 7. So the only other one we have to figure out is f of 2. Well, if we go back up here, remember f of negative 2 is 7. So if we integrate from negative 2 to positive 2, we have to take that integral plus 7, but that integral from negative 2 to positive 2 is negative 2 pi, because that's the area of that semicircle, which is below the x-axis. So it's going to be 7 minus 2 pi. And you have to figure out which of these is the absolute minimum. Well, let's see. 7's not going to be, because 7 minus 2 pi is less than that. 3 could be 10 minus 2 pi. 10 minus 6.28 is not going to be less than 3, so that rules that one out. We ruled out that. The question is, which is bigger, 7 minus 2 pi or 7 or 3? Well, pi is 3.14, 2 pi is about 6.28, 7 minus 6.28-ish is definitely less than 3, so the absolute min is 7 minus 2 pi at x equal 2. So let's take a look at the scoring on that. 1 point for considering x equal 2, 1 point for the justification. And for the last part here, they are asking us to find f double prime of negative 5 and f double prime of 3. Well, f double prime is going to be the rate of change of f prime, or shall we say the slope of f prime. We have a graph of f prime, so f double prime of negative 5, here's negative 5, so we need to find that slope. So that slope is negative 2 over 4, so that's a slope of negative 1/2. So that's our f double prime of 5. F double prime of 3 is the derivative at that point, and you know that we cannot have a derivative there because the slopes from the left and the right are different. Find the value or explain why it does not exist. So in part D, we're going to need to say f double prime of negative 5 is equal to negative 1/2. F double prime of 3 does not exist because the slopes / derivatives of f prime from the left and right are not equal. Let's see how they score that. 1 point for f double prime of 5, 1 point for f double prime of 3 with an explanation. Basically, they are saying the same thing that we said. If you take a look at that, those are the derivatives from the left and the right of x equal 3.